Hello and welcome to Tribe Topper. I'm Sonal Gupta, and this channel is about increasing your understanding of physics. To clear your concepts, subscribe to our channel and click the bell icon for latest updated videos. In this video session, you're going to learn about the electric field. So, what do we mean by electric field? As we talked about gravitational field in our previous videos, I told you that it's basically the space around a mass where its effect could be experienced. Similarly, if I have, say, a charge, plus Q charge placed here, and there's another charge, if I place it in the vicinity of this plus Q charge, it will be attracted or repelled based on the nature of the charge. So, if I pull it very far off, it may not feel that attraction or repulsion. But when it enters a certain region, it starts experiencing that influence very strongly. So that region would be known as the electric field. So we have the similar definition here, that the region of space around a charge within which its influence can be experienced by other charges is called electric field. And how do we determine the electric field strength? So electric field strength means how strongly it attracts or repels the other charges, right? So that would be stated as electric field strength. E is the force experienced per unit test charge. So if I have this charge as small q, which is experiencing the field of this charge capital Q, then E is equal to force experienced per unit test charge, F by Q. If you remember from topic 5, we have done Coulomb's law. That is, if these two charges, capital Q and small q, are brought closer together and they attract each other, then that force is given as KQ by R square. So that force divided by, which we call as Coulomb's force, if I divide it by small q, that gives me the electric field strength. So small q would cancel out here, and I get the expression for electric field as KQ by R square. See, you can use both the expressions, F by Q or KQ by R square, depending upon what information is given in the question. We are also going to do one more expression for the electric field. So we just learned that E is equal to F upon Q. So if I want to find out what is, F upon small q. So if I want to find out what is the force, then that can be determined as Q charge times the electric field strength, E. Right? Now, when we are moving a charge, there is some work done to move the charge. So let's say that a charge is moved by a distance d and we bring it closer to this point P. So when we have moved this charge by a distance d, what is the work done? That will be force times distance to move this charge. And force is QE, that times d. This is the work done. Now, what is the potential difference between the two plates? So if I say I have two plates, one is positively charged, one is negatively charged, then d is the distance between these charges. So when your charge is being moved and there is a potential difference, as you can see, one is at positive potential, the other is at negative potential, and if there is a potential difference of V applied to this, then how do we give that expression for potential difference? Potential difference V is given as work done per unit charge. So that means it would be QED upon Q. So Q and Q cancels. Therefore, what is E equal to? That's V upon D. Because if V is equal to ED, then E is equal to V by D. Therefore, we would say that electric field strength can be given in two ways. Electric field strength can be given as force acting per unit charge, or it can be given as the potential difference over the distance moved, right? So this also leads you to KQ by R square. So these are the three expressions. They all represent the strength of the electric field. And the unit of electric field would be Newton per Coulomb, because it's in fact it starts from the basic formula of force per charge. So Newton per Coulomb. So that's all for this video session. In the next video session, you're going to learn about the electric field strength, its relation to the surface charge density. Thank you.